class, and welcome to lesson 6.3, variables and expressions. So we've been introduced to variables since the very beginning of the year. Who would like to raise your hand and give me an example of a variable? Ella, what do you think an example of a variable includes?
A variable is like a letter that you can use to replace a number because you don't know what the number is yet.
Look at that, that's great. A letter you can use to replace a number since we don't know what that number is, such as X, Y, Z. That's great. Does anyone else have an example of what a possible variable could be? Other possible variables, any sort of symbol if we really wanted, to represent the unknown. I don't know what it is yet. So because it's a variable, that number varies. I don't know if my variable, I don't know what the number is for it yet. So I use these letters or I use these symbols, typically letters, typically X, and then later Y as well, to help me. So when I write the problem, I'm able to solve it later. So I won't be able to solve the problem right away because they don't tell me what the number is. They don't tell me what the number is. So I'm going to have to deal with that after. So for example, in this case, I used a question mark to do the variable. I want you guys to figure out the missing number. What is the answer for these problems? So figure them out for me. Every single person who wrote in the chat has gotten it all correct, which is good because we think, hey, this is pretty easy. This is baby math, right? So we all know this. We got our answer for this first one to be 9. We got the answer for the second one to be 360, and we got the answer to the third one to be 14. Now, we all know how to do it, but here's the proof. Here's how we do it. So let's look at this one. I want to get this question mark all by itself. I want to have question mark equals something, right? Question mark equals something. Something is in the way of me just having the question mark all on its own. That number 131 is in the way of me having my question mark all on my own. So I want to get rid of it. I can get rid of 131 by doing something. So let me ask, if I have $131, how can I get rid of it and have $0? Marley, what can I do to get rid of that?
Spend it.
You spend it. When we spend, that's the same as subtraction. So I'm going to subtract that 131. I want that gone. Mind you, I don't actually want to lose $131, but here we are. However, in math, who remembers our chant? What we do to one side, we do to the other. Perfect. So do you see there's another equal sign, and I put another minus 131. What that statement right here is telling me is that negative 131 is equal to negative 131. That's just a fact, right? We can all agree that that's 100% true. Those two numbers are equal to one another. Yeah. So then I'm going to get rid of this. 131 minus 131. That's gone. And all I'm left with on this side is just my question mark. On the other side, 140 minus 131 gives me 9. So there's our proof of how we did it. Let's think about this next one. I have something minus 6 is equal to 354. Remember, I want to just get down to that something equals. Who can tell me what's currently in the way? What's currently ruining my problem for having it be something equals? Dolan, what is it?
6.
Yeah, 6. Specifically, minus 6. So we see that minus 6 there. How can I get rid of that minus 6? I want to get back to 0. Lucas, what can I do?
To get back to 0, wouldn't you have to subtract 6 and then turn it into a negative 6?
Ooh, that's a really good idea. Currently, I have negative 6. So if I have negative 6, how do I get to 0? Ooh, really good. Let's see, Camilla, yes? You add 6. Currently, I owe someone $6. So once I give them $6, now I'm at 0. Negative 6 plus 6. That's the same as 6 minus 6. But what I do to one side, I do to the other. See, isn't 6 equal to 6? We can all agree 6 is equal to 6. Negative 6 plus 6. Boom, that's gone. 354 plus 6 gives me 360. What about this last one? Again, I want to get down to just my question mark equals. What's currently in the way of my question mark equals, Abner? What's currently in the way for problem 3? Perfect. Abner mentioned that we've got that 210. I want to find out what my question mark is. I want to figure out, hey, what that is. So based on that, Lucia, how am I going to get rid of that 210? It's a positive 210. How am I going to get rid of it? So I spend it. Exactly. So I take away $210. Again, what I do to one side, I do to the other. 224 minus 210 gives me 14. And right there, that's the proof that I have to show how I got 9, 360, and 14. 9, 360, and 14. So when I'm doing this, all I did was show the proof. I did the same to one side as I did to the other. I want to get down to that question mark, to my unknown. Now, I want you to write this down. Here are the 3 ways to write multiplication problems. So if you see any multiplication problem that looks like this, for instance, and it could be written with numbers as well, I just put X. It could be 5 times 4. It could be 5 parentheses 4. However, in that case, it can't be like that because that's just the number 54. But these are the ways that you can write down multiplication problems. If things are touching, it means multiply. This 5 is touching the parentheses, means multiply. This 5 is touching the X, it means multiply. We even have the little multiplication dot for that one. So these are the 3 ways that you will see multiplication problems being written. Then here are the 2 ways to write division problems. We can have 5 divided by X or 5 over X. Because remember, that division sign just stands for placeholders. Just stands for placeholders. And the first one goes on top and the second one goes on the bottom. So now we're going to do a lot of solving problems and you guys are going to make sure you show your work. So this says evaluate if B is equal to 25. We're going to look at that first one together. It tells me what number B is equal to. It says B is equal to 25. So I can just plug that in. Boop. 16 plus 25 is equal to. Same thing with the other ones. I would just plug them in. Delaney, what did you get for the first one?
I got 41.
41. Perfect. Literally, we just add those 2 numbers together. They told us what this unknown variable is. I plug it in. We get 41. Camilla, would you like to walk me through how to do the second one?
Okay, so for the second one, x would equal 64, y would equal 27, so you would do 64 minus 27. You need to borrow from the 6, so it would be a 5.
Yeah, so she does this when she's doing her up and down math. And what do you get as your final answer?
I got a 37.
Perfect. So we see that she just plugged in exactly what it told us. It says right here, x is 64. So for x, I just put 64. It says right here, y is 27. So for y, I just put 27. And I followed the problem. So think about this one. Again, x is equal to 1/2. Remember, these things are touching, which means it's multiplying. This is the same as 6 times 1/2. Remember when we know how to multiply with fractions, we make them both fractions. 6 as a fraction is 6 over 1. And we either across multiply or we can cross cancel first. So Amelia, how did you solve this first one?
Okay, so how I solve this first one is I put 6 over 1 and then x equals 1/2.
Perfect.
So, and I multiply that. And then
because you're able to cross cancel 6 and 2.
Excellent.
So 2 becomes 1 and 6 becomes 3. And then you multiply, which is, it goes 3 over 1, and you just get 3 because anything over 1 is a whole number.
Excellent. So 3 over 1 is just 3. Just like how we multiply fractions normally, we cross cancel if possible, and then across multiply. We cross cancel and then across multiply. Had she not cross canceled, she would have gotten 6 over 2, which she can simplify again to 3, because this means 6 divided by 2, just like how we write our division problems. And so we know it's that. Perfect. Let me see. For the next one, Eduardo, how did you solve this?
So, since you said let's say the x,
Mm-hmm.
I get the times it, so I did 5 times 3 equals 15, plus 4 is 19, and 19 is my answer.
Excellent. So he saw, okay, my x is 3. I'm going to plug it in. And he remembers from earlier that when two things are touching, it means multiply. One of the biggest errors that I saw here is that people would write this as 53 plus 4. But that's not how we write it. This means times. Remember, when two things are touching like this, when the exponent is touching, or when the variable is touching something, it means times. So it means multiply. This one's going to be harder, so again, I'm going to help. First, we do exponent before multiplication. So I'm going to plug this in. So I'm going to plug it in. I'm going to get 4 times 1/8 squared. Who can tell me what 1/8 squared is? Who can tell me, if you don't know what the multiplication is, tell me how you would write it out maybe. How would we write it out? Just like you saw in the video 6.2. Ella, yes?
You would do 1/8 times 1/8.
Perfect. 1/8 times 1/8. And just like we did before, just like Amelia did, we across multiply. We get 1/64. Then at this point, I have 4 times 1/64. Now, as I say, I make it into a fraction because we always want to make it into fractions in order to multiply. And thumbs up or thumbs down, am I able to cross cancel anything here? Thumbs up, thumbs down, can I cross cancel anything?
Ones.
I can cross cancel something. I can cross cancel the 4. They are both divisible by 4. Marley, what is 4 divided by 4? 1. 64 divided by 4 gives me 16. So what I get is this answer. I now across multiply again. 1 times 1 is 1. 1 times 16 is 16. I get 1/16 as my answer. Same thing here. I'm going to plug in my A for here. Does that mean it's going to be 10 and 1/5? Does that mean I'm just going to put 10 and 1/5 as my answer plus 7? So I'm going to get 17 and 1/5? No, I'm multiplying. So it's going to be 10 times 1/5. Remember, make them both into fractions. Cross cancel if possible. And solve. Lucas, how did you solve for the second one?
What I did was, I can't really see the problem very much, but that, and I cross canceled, so I put 10 as 2 and I put 5 as 1.
Perfect. We found their greatest common factor of 5. We cross canceled. And then what?
And then I multiplied 2 times 1, which got me 2, and 1 times 1, which got me 1, so I got 2. And then 2 plus 7 is 9.
Excellent. 2 plus 7 is 9. So that's exactly how we do it. We just plug it in and solve it that way. So here I've given us these problems. And at the very top, I've told us what A is, what B is, and what C is. And I want you guys to plug in these numbers and solve. Hannah, what's the answer to the first one? Perfect. So if I plug in the 6 for A, I would get 6 plus 8, which gives me 14. Delaney, what about the second one?
2.
2. I plug in the 6 for A. I'm taking away the 4 that is B, and I get 2. Vahe, what's the third one?
Plug in the 6 for A, plug in the 4 for B, and you get 24. Multiply that.
Perfect, because we're multiplying it. Amelia, what about the last one?
You do 9 over 1 and you plug in the 1, you plug in 1/3 for C, and you can cross cancel, and the 3 turns into 1, the 9 turns into
C plus 8, 14.
Perfect. So we would multiply that across, and we would
I have
get
a question.
3. Sophia, walk me through the steps for number 1.
Okay, so first, the 2D is the first D, which equals to 12. So what I did is I multiplied 2. Oh wait,
Mm-hmm.
so, 2 times 12, I got 24.
Perfect. And then we take away that 5, and we get? Perfect. It is 19. Excellent. Amelia, what about number 2? Tell me what you did.
Okay, what I did for number 2 is, so, I put the 3D in front because it's easier to do.
Mm-hmm.
So, D, you, multiply 3 times 12, which you get 36. Yeah, you get 36, and then you have to subtract that from 50.
Perfect. And what did you get?
I got 14.
Excellent. So she solved the variable first because she's like, yeah, that sounds easier. And it is. I completely agree. And then she did the subtraction last. Perfect. Marjorie, what about the last one? What did you do?
So, so I did the easier part first. So I did the 1 over 3 squared.
Yep.
So 1 over 3 times 1 over 3, which gave me 1 over 9.
Perfect, because we multiply across. We got that, and then you multiplied that times 9. What did you do there?
So 9 over 1.
Perfect. So we get, ignore that. We get 9 over 1. And then what did you do?
And then I cross canceled.
Yeah. Look at that. Boop. Those are gone. They just become 1 and 1. So what did you get as your answer, Marjorie?
1.
Perfect. So all we did is we just plugged them in for all of them. Remember, we have to follow PEMDAS. Parentheses, exponent, multiplication, division, whichever is first in the problem, left or right. Addition, subtraction, whatever is first in the problem, left to right. I want you to go to guided practice, page 452. So we're on page 452. Abner, what did you get for number 1?
I was actually just doing it right now. So I'm pretty sure we do 3. Yeah.
So we do 3 plus.
3 plus m.
And what does m equal to?
I'm pretty sure it is.
So m is 4, so I put a 4 instead. And then Abner, what is 3 plus 4?
I'm sorry. Pretty sure it's 8. No, sorry, 6.
It's 7. Anyway, perfect. I see what we're doing. So we plug in. We see m is equal to 4. So we just plug it in. 3 plus 4 equals 7. Great job. Hannah, what about you for this next one?
You can't do 4 minus 9, so you have to. So 9 minus 4 is 13.
Delaney, what about this next one?
Okay. Okay. So I put well, obviously 12R is 12 1/6 or 1 over 6.
Perfect. 12 times 1 over 6.
Times. Okay. I didn't know it was times, but we had to do cross trade.
Perfect.
So I did 12 turned into 2, and 6 turned into 1.
And then we multiply, and what do we get?
I'm pretty sure we get 2, and then 2 over 1.
Perfect, which is just 2. Vahe, what about number 4?
Okay, so what I got for I'm not gonna say it. So 4m, m is equal to 4, so 4 times 4 is 16.
And then?
Then minus 2 is 14, and that's what I got for my answer.
Perfect, absolutely correct. Pearson, what about number 5?
Okay, so I did 60r equals 60 over 6. Then I divided 6 from 60 to get 10. And then it says that it's minus 4, so I did 10 minus 4, and then I got 6.
Perfect. So, what he did, he had 60 times 1/6. He knew that meant 60 divided by 6. We found the greatest common factor, cancel it out. 10 over 1 times 1 over 1 gave us 10. 10 minus 4 is 6. Camilla, what about number 6?
For number 6, first I did r times 2,
So you did r squared. So you did 1/6 times 1/6.
and I got 1 over 36.
Perfect. So we did that, and we now got 1 over 36.
And then I did 136 times 3 over 1 because you need to turn the 3 into a fraction to multiply.
Perfect. We need to turn into a fraction.
Cross cancel, and 3 would become 1, and 36 would become 12. So
Perfect.
it's 1/12.
Perfect. Excellent work. Last one, Sydney. The amount of money that remains from a $20 bill after Melina buys 4 party favors for $P each is 20 minus 4P. So that makes sense. She has $20. She spends, which means minus, some amount of money, P, on 4 party favors. So it's 4 times the amount of money she spends. Find the remaining amount if each cost $3. So how do I do this, Sydney? Sydney bopped out, so Marley, let's try it.
I didn't do this one because I didn't see it. 20 minus sorry.
So she does 20 minus 4 times 3 because we bought 4 party favors and each party favor cost $3. So how much did she spend total on the party favors?
First we're going to want to do 4 times 3,
Perfect, which is?
which is 12.
Perfect. So we have 20 minus 12. She spent $12 on party favors and she had $20. How much money does she have left then, Marley? Bastion, what's our answer? 8. 20 minus 12 gives us 8. So she has $8 left after buying 4 party favors for $3 each. Your homework is page 453, numbers 1 through 10. So it's 453, numbers 1 through 10.